Hello everyone. So in this video, we will discuss about the garbage collector in Java. So in Java, there is a special process called garbage collector. So we will see what is the purpose of this garbage collector. So before going to this garbage collector, so we have so many programming languages. For example, if we consider programming language C, so in C programming language, programmer is responsible for creation and destruction of the objects. It means while writing the code, programmer will allocate the memory for the object, and programmer is responsible for deallocating or deleting or freeing that memory space so that that memory can be used by any other new objects. So for example, while writing the code, a programmer created the object, okay, by allocating some memory, some space in the memory. And once the usage of that object is completed, then programmer need to deallocate the memory space. But but suppose if he lost the track of the object, it means he lost the track of that object, and the object usage is already completed. It means now the object, there is no use of that object in the code, and he lost the track. It means he lost the track. It means he was not able to deallocate the memory assigned to that object. Okay. Now in this case, what happens? The object is useless, but still some memory is allocated for that object, and we are not able to free up that memory. Okay. Now if the same thing happens with lot of objects, it means if lot of objects are created and space is allocated in the memory for all these objects, and if we lost the track of all those objects and we are not able to delete those objects, means we are not able to free up the memory, what will happen? It will automatically reduce the available memory. Okay, because for creating the new objects we need free memory. Now all the created objects are occupied the memory. It means we don't have new memory to allocate or to create the new objects. So because of this, if you want to create a new object, sufficient memory might not be available, and this will cause the out of memory error. Okay, so this is actual process what happens in other programming languages, but in Java program, and while writing the Java program, programmers are not responsible for taking care of these unused objects. Okay, in Java, while creating the objects, JVM will allocate the memory for that object, and programmers are not responsible for deallocating the memory. Now, you may get doubt like, if programmers are not responsible for deallocating the memory, then what happens to all the unused objects in Java? So for this purpose, there is a special process called garbage collector in Java. So this garbage collector will take care of all the unused objects. Okay. So a garbage collector is the process of managing the memory automatically without programmer intervention. Okay. So the main goal of this garbage collector is it will delete the unused object, and it will free up the memory, and it will make sure that memory has as much as free space for creating the new objects. Okay, so this is the garbage collector in Java. So now we have discussed that garbage collector will take care of unused objects, but how will this garbage collector will know that the objects are used or unused? It means we have created a lot of objects while running a program. So in that some may be useful and some may be unuseful. Then How GC will know whether these objects are useful or unuseful? Okay, we will see that. So when these objects are eligible for GC? So an object will become eligible for GC if that object is not used by any program thread. It means a particular object that is not used by any code or any program is said to be useless, right? Now these useless objects will are eligible for GC. Now, so how can we decide that this object is useful or useless? So in the programming code, based on our programming code, the code which we write, based on that, it will make the objects eligible for GC or not. So, for example, we will see some cases with example. So, in first case, if reference of the object is set to null, then it will be eligible for GC. Okay, and in the second case, if objects created are in the completed scope, it means, for example, a block of code like method is executed and some objects are created in that block and or belongs to only that block scope. Now, if that execution of that block is completed, then all the objects created in that scope or block are eligible for GC. So, if we see an example, so we will see this with an example. So here we see an example. There is a class called garbage collector, and this garbage collector class has three methods. One is main method, which is used to call, I mean, with JVM we will call this main method, and display and split method and split method. So the split method basically it will get string as input and it will split that method, and this display and split method, it will get input as string and it will display the string, and it will create a new object for garbage collector class, and it will call the split method in the garbage collector class. And in the main method, we created a variables s of string, and we call the display and split method by passing the s value. Here instead of null we need to pass s, and we are creating object for garbage collector, and next we are making GC to null. Now here what happens when we call this main method? First it will initialize the string s, and it calls the display and split method, and in this display and split method, it displays the string s in the console, and it created the garbage collector object. So object for this garbage collector, and it called the split method, and after completion of this split method, now the cursor is at 8. So when cursor is at line 8, the completion, I mean the execution of this display and split method is completed. It means this code will not execute again, or this block scope is completed. Now the objects which are created in this scope are eligible for garbage collector, because the objects which are created in these methods which are already executed, those objects are now useless means no one is using, or these objects are nowhere used in the code, only in the scope they are used. So once this block of code is executed, then all the objects which are created in that block will be automatically eligible for garbage collection. Okay, next, when we are at line number 8, here again we are creating a object, garbage collector object, and assigning that to GC. Now here, when we create this new garbage collector, then it will create an object of garbage collector in the heap memory. Okay, and in the heap memory at specific location it will create the object, and the address of that memory will be assigned to this GC. So basically, this GC will contain address of the garbage collector object which was created in the heap. Now, if you want to access the object which was created in the heap through GC, we will access. Okay, because GC contains the address. Using GC, we will get the address and we will go to that address and we can access the object. Now we made GC to null. Okay, we made GC to null. It means here we have object in heap memory. Object is still present, but there is no link to access the object. Right? Am I right? Because previously GC contains the address of the of that object, but now we made GC to null. Now the connection between GC and object was gone. So now there is no link or no route for the object in the memory to access. So that's why now after making GC to null, the object which is available at location is eligible for garbage collector, because this object is useless. This object is useless. It became useless because there is no link for the object to access from the code. So now this object is eligible for garbage collector. So these are the two examples where I explained like objects are eligible for garbage collector. Okay. Now, so now based on this code, we have decided like this GC is eligible for garbage collector, and this GC object is eligible for garbage collector. But how does actual garbage collector process will know whether this object is eligible for garbage collector or not? Okay, it means how GC will identify these unused objects, okay, and how GC will identify these null references. Okay, now basically, um, so we have discussed that GC will identify the unused objects and deletes them. But how will GC identifies the unused objects or null references? So for that, in Java, garbage collector will use the GC root. Okay, so GC root is the main reference. Through GC root, we can traverse through all the objects present in the memory. Now, so this GC, our garbage collector, will traverse through all the objects from the GC root and identifies what it identifies. So if the object is reachable or not, it will identify. So what it will do, the garbage collector will traverse through all the objects from the GC root, and if object is reachable through the GC, then that object is mentioned as a live object, means that object is used somewhere in the code, and the all other objects which are not reachable through this GC root are defined as a unused objects, and those unreachable objects are eligible for GC, garbage collection. And so we identified how can we identify objects which are eligible for GC. Now, how this garbage collector will identify those objects? So basically, garbage collector as a mark and sweep algorithm. So it will use mark and sweep algorithm to find the unused objects and clean them. Okay. So this mark and sweep algorithm has two phases. First one is mark phase and second one is the sweep phase. Okay. Now what will happen in the mark phase and what will happen in the sweep phase? So in the mark phase, garbage collector will traverse through all the object from GC root and marks the reachable objects as live. and all the other objects which are not marked or not reachable or GC routes or unusable or dead objects, and these unusable objects are garbage and are eligible candidates for GC. So we'll see with example. uh, Mark. So here if you see, uh, here we have a GC route. So this is the route. So from the route we can traverse through all the objects. Now, so from GC route we will traverse through all the objects and we will mark all the reachable objects as a live objects or reachable objects. Okay. So here we can see there is a link from this GC route to all these objects. So these all objects can be reached and these are live objects. And here the objects, these three objects are not reachable from this GC route. It means there is no link of these objects to the code. So these three objects are now eligible for GC garbage collection. Okay. Now, now we understood that mark method, mark phase. It will traverse through all the objects and it will mark the objects which are live. Now, in the next phase, sweep phase, what it will do, it will go through all the objects again, irrespective of GC route or any GC route or any flow. It will go through each and every object and it will check whether this object is marked as a live or not, live or reachable. So if this is reachable, it will leave it. If object is not reachable, then it will empty the space and it will free up the memory and it will clean up all the unusable or non-reachable objects to make some free memory space, and that memory space we can use for creating new objects. Okay, so this is how garbage collector will work internally. Now we have discussed garbage collector and how garbage collector will work. Now but when will this garbage collector triggered? So basically, the garbage collector is a process in the JVM or Java. But when will this garbage collector is triggered? So can programmer trigger this garbage collector or how it will be triggered? So once all the objects are eligible for garbage collector, then GC will not immediately free up the space. So you may think that the objects are useless. Then why we need to keep them in the memory? We can immediately call the GC and we can free up the space. So we may think like that, but uh, GC actually won't work like that. So for freeing up that space, GC need to be triggered, and only JVM will control or JVM will decide when to run the GC. So when JVM feels that memory is full, it will automatically will trigger the GC and it will clean up the space. Now even programmers can trigger this GC by writing a code commands. So these two commands like system.gc or runtime.getRuntime.gc. So using these two commands, we can trigger the garbage collector from the code. But so we can trigger this garbage collector, but there is no guarantee that the garbage collector will trigger and it will run the cleanup process. So you feel like once the GC is triggered, it should clean up the space. But when the GC is triggered using these commands, there is no guarantee that it will clean up the space. So only JVM has the access, and when JVM feels memory is less, it will trigger the GC and it will free up the space. Okay. So this is the how garbage collector will work in the Java. Thank you.